back. Just a quick preface, creating some tutorials in Python for fellow students in my cybersecurity bootcamp. If you hear anything I say that is incorrect, please leave a comment and I'll provide that edit to that correction in the description of the video. In this portion, we're going to quickly, probably not too quickly, cover if conditionals, for loops, creating functions, and counting things using the aforementioned items, if conditionals, for loops, and functions. These are a couple methods that we're going to apply in this exercise. I'll try to explain them as we go through, and you'll see me referring to this breakdown frequently as I have not memorized all of this. It is impossible to memorize everything just in Python, let alone all of your tech career. Be prepared to look things up. Don't be embarrassed if you don't know something. Nobody knows everything. So exercise problem one, write a script that receives a word from user input and then counts how many capital letters are in the word and prints the result. I assume the result is how many capital letters are in the word, and a hint here is to use the isUpper method, which returns the Boolean true if all characters in the string are uppercase. Let's start with what Booleans are. Booleans. I just created a variable called Booleans. I'm going to create a list, and I'm going to list out the two types of Booleans, true and false. Booleans are incredibly useful in programming. They're used with if conditionals. When you're using an if conditional, you are asking if something is true, and if it is true, you will execute the code under that if conditional. And then there's often chained with if conditionals the word else, which means if the if conditional did not resolve as true, it resolved as false, and therefore will execute the line of code under the word else. So we'll get to that here in a moment, but a Boolean is another data type, so we'll just replace that list with the data type true, and we'll print out the type of the Booleans variable, and it comes out as class bool. And eventually we'll cover what classes are in Python. That's probably coming up in our lessons. For now, let's get to work. Receiving a word from user input. When we're writing a script with user input, it's kind of a pain to keep testing the script and to keep typing user input, so we're just going to imitate or simulate rather what a user would provide us. Word, let's do user word because it's going to be user input, so we'll specify what it is in the variable. A space between the equals and after the equals, not between but before and after for readability purposes. User word, we'll just have word, and we'll capitalize the first letter and the last letter. The first thing we need to do is count how many capital letters are in the word. So that means we need to create an initial count starting at 0. And this is an integer for 0. And now we created the count. Double clicking ruins it. Receives a word from user input, counts how many capital letters are in the word. So when we're counting, we need to iterate through the string. So we need to create a for loop, starting with the word for. And then we need to create an iterable. This is a variable basically that we're creating in place. We can call it letter, we can call it I, we can call it balls. But we're going to use letter because it makes sense in this loop. For letter in user word. This is indicating the string or the list that we're going to iterate through. We need to close this with a colon. And then for letter in user word, that means we're telling the program to iterate through this. So it's going to start here and check it. It's going to go to the O and check it, the R and check it, the D and check it. It's going to check it with whatever we put here in the next line. And we need to ask if the letter is capital or not. So if letter, and we're referencing this variable that we created in place here, if letter dot is upper, so here we're using this method added on to this variable, and this is basically checking the letter, and it has back-end code built in that's going to say, is this uppercase or lowercase? If it is uppercase, it's going to return true. If it's lowercase, it'll return false. And if I just add a colon right here, this by default knows that I'm going to look for something that is resolving as true. We could also probably put equals true, and the double equals is different than the single equals here. This is an assignment operator. I think this is an equals operator. Basically, it means is this the same as this? And this part, deleting it, this means the same exact thing. Now we press enter again, it auto tabs for us. We do need to have a tab here indicating that this line is within this for loop code block, and then the if code block that lives inside the for loop, we're going to execute a count. So if something ends up being capital, it'll be true and it'll execute this code, and that means we need to add 1 to the count. So plus equals count plus 1 would be the long way to do it. In the course, they did teach us a shorthand way to write this. Count equals count plus 1. You can also write count plus equals 1 for the same exact thing. So this is the same as count equals count plus 1. And we're basically saying if it is an uppercase letter, we're going to increase the count by 1. And we don't need to add an else statement because we don't need to do anything if the letter is not upper. And this for loop is going to iterate all the way through the list until the end, and when it's done, it automatically stops the loop. And we go to the next line of code where we need to print the result being the variable count, I do believe, count. And we can be fancy and add some context to this. Uppercase letters in your word. And then let's do a space so it gives it a bit more pretty formatting. So we've got the user word without the input yet because we're just simulating that. We're going to test this one, which should output 2 as the count. We are creating a count variable starting at 0. We're creating a for loop to go through this string and check each item in the string to see if it is in fact uppercase. If it resolves true, then we increase the count by 1. If it's not true and is false, nothing happens and it just goes to the next item in the list, the for loop that is. So I think this is correct. And I ran the code by pressing Shift Enter, which is the same as pressing the play button here. And it looks like we don't need this because it's giving us 2 spaces here, and I like it to be pretty. Uppercase letters in your word, there are 2. Let's change this so that there's 1 and run it again, and 1. Perfect. So let's move right along now that we've completed all of these steps here using a for loop, an if statement or conditional, and a counter being built by these 2 items here, and of course the for loop as the engine that adds to the count by iterating through the list or string. Problem 2. Write a script that we forgot to do our input, you guys. Input quotes to create a string. Give me a word. It can have capitals because I'm gonna count it. Capitals. Capital letters. Wow. Wow. 1, 2, 3, 4. 4 capital letters. And wow, wow, wow. All right, next up. Write a script that receives a word from a user input. Word equals word. We need to check how many characters are in the word. Print the result is alphanumeric. I'm not going to do all this because it's like a repeat. So I'll probably skip this one because it's just asking, is it a number or not? But alphanumeric returns true if all of the characters in the string are alphanumeric. And alphanumeric is, are they letters in the alphabet or are they numbers 0 through 9? Other items that there might be in text would be special characters like exclamation marks and things. They would be living within the ASCII characters, which are a computer encoding of most of the characters in like language, so letters, special characters, numbers, etc. All right, alphanumeric. You know what's fast is copying and pasting. And since we're doing something super similar, we need to ask for, give me a word for your gamer tag, probably, because it can be letters and numbers like XX 69 420 Slayer. Oh, Slayer XX. That's not my gamer tag. All right. These are all alphanumeric. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're expecting to see 15 if they are, in fact, resolving true as alnum, which is the method here. We're just replacing the is upper that I copy and pasted. User word, referencing user word. It's not really just letters anymore, so let's change this. Chappelle, more accurate, more readability for characters in user word. Check if it's alphanumeric, and if it is, if it resolves as true per this if conditional, we're going to count 1 for it. Alnums in your word. Oh, paste it, baby. 15. All right, we got it. Hopefully that makes sense. Let me know if you have questions in the comments. I don't care if you upvote this or subscribe. Just learn. All right, problem 3. Receives a word from user input, counts the digits. So basically, it would be counting this word as an example and just counting the numeric digits. We're not going to do it because it's a repeat. You should be able to gather from this and the previous one what it is. If you get stuck, just leave a comment. All right. Problem 4 is different, so let's do it. List 1. Just a reminder, capital letters at the beginning of a variable are not considered really great practice. Per PEP 8, maybe per Hitchhiker's Guide to Python, use lowercase letters. The underscore is a good idea when you're adding different words. So I would do list 1 for best practice. Let's go ahead and copy the list and paste it with Control-C, Control-V. Loop over this list, check how many words have a length of over 6 characters. So we need to loop over a list. We need to look at each word and count if it has over 6 characters. That makes me think we want to use the length method to check the length or number of characters in the string. We're also going to end up using a greater than symbol, most likely. And we're going to use a counter because we're counting. So let's create that variable now. We need to loop over the list for a list 1. Whoops, no, for words in list 1. So now we've created our loop. Now we're going to create the code. So loop over this list and check how many words have a length of over 6 characters. So we need to say if words, we're going to refer to the words because in this one we have full strings as items in the list. So each iterable words, let's do single so it's more clear. For word in the list, it's going to check the whole word. We need to check the length of the word, so we're going to use len for length to output a number because it's going to count the character in each word of this list. If it's greater than 6, length of over 6 characters, we need to add to our count. Count plus 1. And again, each time it has over 6, it would add a 1 to this count, updating the variable, but we can do the shorthand, plus equals 1. And let's see, looks like we're going to have 3. So we go to the next line, we start at the beginning of the line for a new set of code. We need to print, we can just print count to start, but we want to get a little fancier for context for the user. Number of words with more than 6 characters. Let's try it out, guys. 2. Oh, this isn't. So Croatia, Albania. So USA, France do have 6, but not over 6. If we wanted to do length of 6 or more characters, we could do greater than or equals. So that means it's either more than 6 characters or equal to 6 characters. But in this exercise, we want more than 6. So that looks complete. Let's move to the next one. We're moving to problem 5, which is a bit more complex. We do need to get some user input, pretend we're entering a password or the user is entering a password. It needs to check if it has a capital letter, at least 1 digit, at least 1 special character, length of it is more than 8. If all conditions are met, Princess, this is a strong password. A lot of different ways to do this. I'm trying to think of the best way to do it. I think I'm going to create multiple counters, and as it iterates through, it's going to check if it's a capital letter, it's a digit, it's a special character, or if it's length of more than 8 total. And if all conditions are met, if any of those counts, or rather if all of the counts are at least 1, then it's going to print this is a strong password. These are a couple things we've learned in the class so far. So let's just do a simulated input first. User PW equals. Don't use this password. Password 1, 2, 3. Don't use this password. It's not safe. It is meeting all of the standards, but it's a pretty generic password. All right, so it's got a capital letter, it's got digits, it's got, let's just shorten it so it has 1 of each that we need. It's got a special character, the exclamation mark, it's got more than 8 characters total. There's many ways to do this. There's probably a better way to do it. But what I'm going to do is start counters. So capital letter counter. I'm going to do, I can't remember what this is called, but it's multiple variables in a single line. Has cap. Let's do has cap counter. No, let's just do cap counter. Dig counter. Love the dig, the didgeridoo. 1 digit, 1 special character, counter, length, counter. So we're going to check if it's more than 8 characters, and if it is, we're going to say yes, it has more than 8, so it's going to add 1 to the length counter equals, and these are 1, 2, 3, 4 variables, so 1, 2, 3, 4 variables. Probably need a space for readability, but there we go. So now we have 4 counters to count each one of these. Oops, I ran the code. I'm just needing to press enter, not shift enter. So let's do this hacky. So we need to check if it has at least 1 capital letter. If nope, we need to loop through to check each character. For character, I'm going to shorten it to care. In user PW, if character dot, we need a capital, so is upper, capital letter counter plus equals 1. So that's checking if it has capital letters for each letter in the user password. And then now we need to check for digits. Digits. For dig in user password, no, we'll just want to use care because we're still just looking through characters. If care is numeric, I just looked at the reference, the hint up above, is numeric, and update the dig counter. I'm going to copy it again and paste it. I tried to do this before and I wrote it wrong. I tried to chain a bunch of ifs together and it was just not working out. So I got stumped on that path, so I decided to take a break and think about it and come back to it. That's one of the biggest tips I can give you in programming is if you're having trouble and you're stuck. Number 1, rubber ducky debugging, talk out loud to an inanimate object and explain what you're doing. Thanks, Olama, for the update. And if that doesn't work, take a break, go take a nap. You might even dream up the damn solution. It's crazy. For character and user password, we need to check if it's a special character. We need to check if it's a special character, and none of these, as I recall, check for specifically special characters. This checks for numbers, this checks for letters, this checks for anything in ASCII encoding, which is basically special characters, letters, numbers, everything. So we need it to not be numeric, we need it to not be alpha. This is alnum, this is letters and numbers, so alnum. We need it to fit this, but not fit this. This includes too many because it includes letters, numbers, and special characters. So I think we want to do anything that isn't letters or numbers to then mean it's a special character. So we're going to add a new item in here. If not care dot is alnum. So we're saying, is that correct how we wrote it? Alnum. Yep, is alnum. If the character is not in the alphanumeric list, we don't want this to be true. Well, we want it to be true, but then everything other than that is correct for us. It's a little confusing, but we're basically saying we don't want letters, we don't want numbers, So we do not want whatever counts within this method is alnum. Special counter plus equals 1. So that looks good for now. I could be wrong, but let's just hope I'm right. And then we don't need a loop to check the length of the full variable. We need to say if length of user PW. There's a lot of different ways to do this again. It's only going to count 1 if it's correct, but we want it to be more than 8, greater than 8, length counter plus equals 1. And what we want to see is all of these being 1 or more to be a strong password. That means we have at least 1 capital letter, at least 1 digit, at least 1 special character, and a length of 8 or greater. So now these all should output the cap counters as 1 because we chose a password that counts as a strong password per these specifications. So now we're going to check or have Python check if all of these numbers are greater than 0. So if cap counter greater than 0, and now we can chain all these together with an and dig counter greater than 0 and special counter greater than 0 and length counter greater than 0. Now finally print, this is a strong password. And if all of those are not met, if all of these do not have a count of greater than 0, it is not a strong password, it is a weak password. This is a weak password. Okay, again, probably a better way to do this, but this is an initial hacky way to complete it. We've established the password as a variable. We've created counters for all our requirements. We're running through each of the requirements and counting a +1 if they match a requirement as they iterate through each character. We're iterating through the correct variable each time. We're checking the length at the end without looping through because we just need to check the whole darn variable for this. If it's greater than 8, we do a length counter +1. If cap counter greater than 0, dig counter greater than 0, special counter greater than 0, and length counter, if all of these are true, then it's a strong password. If we had OR here instead, any one of these single items, if we replace all the ands with ORs, any one of these single items could be greater than 0, and this would print that it's a strong password, but that's not what we want. So let's try this. This is a strong password. Let's delete the special character and run it again. Now it's missing something, so it should be a weak password. This is a weak password. All right, perfect. All right. Feel free, please, to share a refactored code of this. It's probably some LeetCode one-liner that your brilliant mind created. I would love to see it in the comments. I don't care about upvotes and subscription bell whatevers. Just learn and feel free to teach me something. All right, this looks correct. We need to do the last thing, receive user input. So we need to replace this with some instructions. Enter your password. It needs at least 1 capital letter, 1 digit, 1 special character, and more than 8 total characters. That's a lengthy input instructional. Let's test it. Help. It's a weak password. We didn't add all the stuff we needed. How about password 1, 2, 3, add? Boom, strong password. We got it, guys. But this is kind of lengthy. It's cumbersome. There's a couple different ways we could do this. We could print out an instruction above this first. Prepare to enter your password. It needs this stuff, and then enter password. So now it's going to be a little cleaner looking. Prepare to enter your password. It needs all this stuff, and then enter the password. Let's call it a day on that one. Write a script that prints every 7th number between 1 and 100. Sounds like we need to use the range method. Let's try. Let's just get started. For number in range 1, starting at 1 to 100, print every 7th number. So I'm just guessing here, but I think that's going to jump like slicing the third item. Print number. Pending input. Cell has not been executed. Oh. Pending input. Read your errors. Now it's going to be cleared up. So we're printing every 7th character, every 7th number between 1 and 100. Well, between 1 and 100, so we're jumping 7. We're ending at 99, however, because counting in programming starts at 0, so 0 to 99 is 100 counts. So let's do a +1 here to actually complete it at 100. Still though, we're jumping 7, so it's not actually going to output 100 because 92 plus 7 is 99, so that's the last one in the list. But we're starting at 1 in the range. A range in a loop like this creates a range of numbers for you. Starting at 1, ending at 100, +1. We don't actually need that since it stops at 99 anyway, but it does instruct us to go up to 100 and count every 7 characters. So we've done that. Problem 7, write a script that receives 2 inputs, iterates over the values between the first and second number inclusively, so it's going to include. We're going to need something that's divisible by 3 and 5, so we're going to need to use something called the modulo, that guy. It's an operator like plus, minus, dividing, multiplying, and the modulo, which is a remainder. And if we want it to be divisible by 3 and 5, if it's divided by 3, a number, the remainder needs to be 0 for it to be divisible by 3. If we're dividing a number by 5, it needs to be 0 when we're taking the remainder. So like 15, it's divisible by 3 because 15 divided by 3, pardon me, gives you a whole number with no remaining extras. 15 divided by 3 equals 5, not 5.1 or anything like that. 15 divided by 3 is 5, a whole number, which means there's no extra remaining digits. So, receives numbers, iterates over the values. So first we need to, let's simulate an input. Numbers equal, let's do user numbers. It's going to output as a string, so let's do a string. Let's do 20 to 30. And it wants us to iterate over the values between the first and second number. So the next thing we need to do is split this into a list so that we can iterate over the values. And the split without anything in it is going to split it with the space, much like indicating this would do. So that's going to create a list in place of this. Let's just print it to check that we're correct before we continue on and make assumptions. Yeah, it splits it into a list that we can now iterate over. Iterates over the values between the first and second number for number and range. And here, we don't need to just put numbers. We can feed in variables. And what we can do is access the list indexes of the list we're creating that we tested by printing. So the first position, which is going to be the 20, is the starting point of the range. That should be inclusive by default. And then this one might not be inclusive by default. User number position 1. So we're saying in the range starting from 20 going to 30, and we'll say print numbers, and it's probably going to print up to 29. Error, user numbers is not defined. User number is not defined. I just didn't reference the variable quite correctly, and let's run it again. Another one, string object cannot be interpreted as an integer. Right now, these are string objects living in our list. So right here, they are also string objects. When we access the list, let's convert them in place. It's called typecasting, where we're converting it to an integer. Let's do another one. Let's run it. Bam! Look at that. Now we need to have it inclusive, which means it needs to include the numbers it's referring to. It needs to include 20 up to 30. The range counter starts at 0 and counts for 30 characters, which ends at 29. We need to do a +1 after it converts to an int. So +1 here. Let's print that sucker. Boom. All right. Iterates over and then prints every number that is divisible by 3 and 5. Okay, so now we need to replace this and print out only numbers divisible by 3 and 5. So if number modulo 3 equals 0. So I think I'm saying here if the number is divisible by 3 and leaves a 0 as the remainder, and if number, this reminds me of FuzzBiz exercises. Number, look that up, FizzBuzz, FuzzBiz, FizzBuzz. 5 equals 0, print, and let's do an F string. This F string makes strings smart. Now we can refer to variables in these quotation marks. The number, using these curly braces, we can say number is divisible by both. Oops, here we go, watch this. We forgot to keep it inside our quotes. By 3 and 5. Invalid syntax. We don't need this, the second if. If number is divisible by 3 and number, same number divisible by 5. If both of these are true, then print. Let's try around. Okay, let's see. So we are iterating through but when we're iterating through, we're not creating anything for this to look at. how do you create a list in range? So we don't need to iterate through a loop, we need to create a list with this range. User list equals I don't know if that's correct, but I'm going to test it. I'm going to comment this out with control /. Let's see if this creates a list. I could look it up with the documentation, but let's just print it and see if it creates a list with the range automatically. No, it does not. 20 to 31. So let's try, I could just ask ChatGPT, but I'm stubborn. This is a way to typecast a list. Probably not necessary here, but it's a kind of a Hail Mary. Print user list. Alright, so we're giving it a list in this range as far as the numbers it needs, and then we're typecasting it as a list. 20 to 30. So now we have a list that we need to work with. So let's say for number in list. So now we're going to iterate through the numbers in the user list. Oh, see, so that's interesting. Tab, if number is divisible by 3 and number is divisible by 5, print it. Or any of the numbers in that list divisible by 3 or 5. Let's try this because we'll expect 15. Boom! All right, we're in business. Okay. Now we need to take two numbers from user input. That's the last thing. Input. We need to still split it though, so we'll do that after. Please provide two numbers with a space in between. Okay, so we need to then split it on its way out. So it takes the input and it splits it. Cool. All right. That's that. On to the next one. We're going to skip this one. You need to create a variable with a string of all of the consonants. You need to create a list in that same string of all the lowercase consonants and all the capitalized consonants. You need to compare that list to the words from the user input. I would imagine that you're going to have to chain two loops together. You need to iterate through the word and you need to iterate through the list of consonants. I'm going to let you do that one because I want to keep moving forward. Feel free to use some documentation. It's going to probably look like something similar to for user character in user input, then a colon, and then a tab, next line, tab, and then a next line, and then a tab, and then for letter in Word. Oh, jeepers, I'll just do it. All right, we're writing a script. Receives a word from user input. User word equal. That's good practice. Test word. I'm going to use ChatGPT to give me all consonants to save some time. And I use Gemini, Google Gemini. It accepts more text, more tokens. Please give me all consonants in English alphabet, both upper and lowercase. Put it in a variable called consonants for Python, like this. Consonants equals your output. Let's see if that works. Goodness gracious, thank goodness. All right. Do you think Y is a consonant? Who can really say? Nobody really knows. All right. User words, test word, consonants, all of those. We print how many consonants are in that word. So we need to check each of the letters in the user word and compare it to the consonants. 4-letter in user word. So now we're iterating. So at letter T, we need to then compare it to each of these 4-letter in consonants. For letter in word, check T, then we'll iterate through all the consonants. If let's be more specific. We need to make these two different variables so we can talk about each of them separately. If the letter of the user we need to count too. Count consonants, const count. For user letter in user word, so we start at T and we iterate through each of these just for T, and then when it's done, it iterates through the next one and goes through this to compare it all. If user letter T, and then for any of these, if user letter equals const letter, const count plus equals 1. So that should iterate through every one of them. It should compare consonants upper and lowercase. I'm sure there's a way to use is upper method on this, but we're just going to print the count. Let's do easy way. Const count are this many consonants in your word. 6. 1, 2, 3, 4, 5, 6. All right, so this can get complex, and I always have to visualize it and look at it. For user in letter words, so we're iterating in that loop through each of these characters. When we iterate through the very first character, then it jumps to this one, and then it iterates through each of these characters until it completes. And when it completes, it's looked at this one, it's looked at all these ones, and then it runs this and checks it. and then it restarts and goes back, and it starts on this guy and iterates through all these, and if it matches, it adds to the count. You'll probably see that in actual coding examples. A lot of the times they use I and J for these examples, for this particular structure. Oops. But we'll be more concise and add some more context for the reader. Iterates over a list, count how many times port 80 appears. We can count that. We know how to iterate, prints the result. Syntax, we're down to functions. Let's see. We've seen and used functions, comes with prepackaged, I keep saying built-in, prepackaged built-in methods like the print method, the int method, the typecast, the, what else was there, input, like that. They said print. What other functions have you used? We just named a couple. While built-in functions are useful, we can define our own. And this is the layout of defining a function. You need to add def. This would be your custom function name. This would be parameters or arguments that you would feed into your function. Much like when we use the length function, len, and then the parentheses, we put our variable here and it outputs a number for us. It counts the length here for that piece of code in the length method or function, and then it returns the number as an integer, probably as a string, I can't remember. I think it's an integer though. Start of the function is def. Well, we ruined it. Function name is the custom one that you are choosing. You need to finish this with a colon as well, and then the code needs a tab. Run the code, and then this return is very important. It does say optional, but when you want to end the code, returning a value so that you can use the outputted value somewhere else, this is what does that. Optional because you might just want to print something out instead of returning anything to use elsewhere. There are some other items there that can probably kill a function. I can't remember, maybe exit or quit right now, but we'll pass on that. I think pass is another one. So this here is a function called greet that simply puts good morning as an output to terminal. This does not return anything. Calling a function, you create it here, you define it here, and then you call the function here later on in the code. This isn't going to run, I don't think, because we don't have any code function created in this particular code block. Greet is not defined. So if we paste this sucker in, bingo. Let's try it again. Good morning. Let's be more traditional. Hello world. You can call it as many times as you want. You could paste this over and over and over and over. And it's going to call this guy every time. It's a reusable piece of code. This is string concatenation with the pluses in between the first string and then a variable which gets fed in. This is where we're feeding in a parameter or an argument. So we call the function down here. It reads basically the way Python works or codes work is first it goes through each line and interprets what it means. And then at the end, then it starts executing. So it understands what all this is. It knows it. It saves this creation of the function. Doesn't do anything with it yet until we go here, and it executes the function entering the argument Paul for the name. The name gets fed right into here. So Paul would output as a string here. Best practice, in my opinion, add double quotes. Greet Tim. This is going to say, hello, Tim, good morning. This is going to feed Sarah in instead of Tim, Sam in as an argument. you can have multiple arguments, multiple parameters in a function separated by a comma. It's good readability to have a space. And you need to feed it in the same order as you created the parameters. So Monica being the name, comma, good morning is the message. Hello name feeds in the message, or feeds in the name and then the message, concatenating the strings with some formatting and some greeting. Go through the demonstrations. Make sure you understand them. If you have any questions, leave the questions in the comment. Write a function called reminder. Let's start with an exercise or two. So we need to write a function. So define a function. We're going to call it reminder. We're going to leave a colon at the end. Accepts two numbers from a user. So number 1, number 2. These can be whatever we want to call them. We just have to reference it with the same exact name. Prints the modulus. Print num1 modulus num2. And we got to call a function, else nothing happens. So reminder, let's do 15 and 3. So 15, oops, you know, we forgot. I said it needs to exactly match, and then I didn't exactly match it. Boom. Reminder, 15, 3, it's going to do 15 modulus 3. And it's going to print it, because we told it to in the function, 0. Let's do 4, 3. So 15, I'm not going to try to do that math. So 15 divided by 3, there's 15 divided by 3, 15 divided by, oh my gosh, math. Makes sense in my head, but I can't say it in words. Each time this divides by this, there's 1 left over. Goes in 3 times. Something. Look it up on ChatGPT. Modulus, I have to look it up every time I see it and refresh myself on it. Something that just doesn't seem to stick. Write a function called print list that takes the list, my list, as an input. Parameters can take any data type, lists, numbers, strings, even booleans and stuff. All right, takes a list. Write a function, so we need to define a function called print list. It takes, we need to close it with a colon, it takes my list as a parameter, as an input or an argument. Prints all of the elements in the list for element in my list, print element. So we're printing all the elements in the list by iterating it through it, for element being the iterable, and then going through each item in the list and printing the element. And we need to call the function. So let's first create a list right there, my list. So the Python program is going to walk through this and know that the function exists, and it's going to see the list and know that it exists, and then we're going to call the function, my list. And let's try printing it. There we go, it prints it. So something interesting, this parameter name doesn't need to match these. Let's just do underscore to make it different. These two, my list, it needs to know what you're referencing in this function call. And then it automatically knows that this is related to this guy. And the function call is defining itself and looking for one argument So we could change this to list. Oh, no, we don't. See how it turned green? It's a built-in word. So it's a reserved word, I think it's called in Python. You can't use it for programming. It's used for other stuff. You can use it, but it's got its own built-in uses. So you can't use it for other stuff. All right, that's a start. Return statements, we'll do one of these and then we'll stop. I explained return statements a little bit. This is defining a function called sum. It's taking two parameters, two arguments, two inputs, x and y. It's returning x and y. Let's just run it and see what happens when it returns it. So let's do 1 times 2. That's going to equal 3. It's going to return 3. Now it returns it. In actual coding, I don't know that this would output anything unless we told it to print. So what we could do is say number or sum, function sum equals, and then we could print function sum, also 3. I'm going to take this code and put it into VS Code real quick. VS Code, I covered it in the previous class slightly. It's a code editor more commonly used, and it's what you'll see in practice when you're actually writing code. Creating a new file, we're calling it test. We're keeping it in that workspace. I'm going to paste this in. I'm simply going to call the function, and we're going to look for output down here. You can see all my nasty file paths. Don't hacks me. Let's run the file and see what happens. So you can see that there's no output occurring in a real program because we're not telling it to output it to terminal here. We're just basically telling the program to know that there's a returned number of sum of 1 and 2. Now, if we print the call function, the function call, that should work, and that should print out a 3. Bingo. So the lab is a little misleading here. When you return something, it's not doing anything with the information yet until you do something else, like we could do sum 2 equals 5 plus the return. So this is going to put in a 3 for itself later. So let's print sum 2. Run the code. Let's see here. 5. Sum 2 is not defined. Well, why not, buddy? Let's see. Trace back. Name error. Sum 2 is not defined. Oh, okay. Actually not okay. Sum 2. We are creating that function sum. Let's get simpler. Let's make it simpler here. 5. Let's print out this. Int object not iterable. We're doing it wrong. I don't want to get too stuck on a small tangent here. Something else to note is that a return should be the last item in a function. So you could print stuff and do a bunch of other code up here, but ultimately this needs to be the last line in the function. Once it hits this line, it's going to exit the function. I'll have to think about why that didn't work. embarrassing to me that I can't do this right off the bat, but I'll have to think about it and get back to you on that. But I wanted to just show you what it actually looks like in an IDE. It's not going to output it like this unless we print it to terminal. Otherwise, it's just saving the returned value in memory until you do something with it. So sorry about that bit of stumbling at the end there. Let me know if you have any questions, corrections in the comments below. And happy learning. Bye.